Okay, so now to solve special case inequality solutions where both solution sets end up being less than different variables. So again, not as much about how to solve it as how to interpret the solution. So we're going to start by solving our first inequality. This is an and, so this is a conjunction. So we start with our distribution. 2x times 4 gives me 2x plus 8. I'm going to subtract the 8 from both sides here, and I will get 2x is less than or equal to 8, which then when I divide both sides by 2 gives me x is less than 4 or equal to 4. So that's one part of my inequality. I'm going to deal with this other set. Now here I can see that I have a fraction, so an easy way to deal with that is to multiply by the denominator of the fraction. In this case, we have no internal parentheses, so I would just multiply every one by 2 here. So multiplies the 4, the 1/2, the 33, and the x. So I know that 2 times 4 is 8. It's an easy one. 2 times 1/2, though, that's actually just going to cancel out the 1/2, leaving me with 1x or just x, because 1x and x are the same thing. 2 times 33 is 66, and 2 times x is 2x. Now it's just a matter of combining like terms, in this case across the inequality. Since we have the variables on both sides of the inequality, I'm moving the negative 2x because it's actually smaller because it's negative. So that will give me 8 plus x, because negative x plus 2x is x, is less than or equal to 66. I subtract my 8 from both sides of my inequality to solve for x. The value of x here needs to be less than or equal to 58. So those are my two inequalities. Now you'll notice both of these inequalities are less than a number, but our key is this is a conjunction and needs to connect our two pieces. So if our answer needs to be less than 4 and less than 58, we need to think about example numbers. So for example, I could try what's a number between those two numbers, 10. So 10, it's less than 58, but it's not less than 4, so that doesn't work. But 3, which is less than 4 and less than 58, works. So when we have a solution situation here where we have two inequalities that are both the same type of inequality. In this case, these are both less than inequalities, and it needs to satisfy both inequalities, needs to tick off both of those boxes. You need to go with the smaller number. So we're actually going to use only the solution that has a target number that's smaller. So as opposed to graphing both of these on here, our solution is actually just the smaller one, because satisfying this inequality also satisfies that inequality. But just because you satisfy x is less than negative 58 with example any number between 4 and 58 is not going to satisfy something needing to be less than or equal to 4. So we are going to do open circle, less than, and this will satisfy both inequalities. That's the key with compound inequalities. We have to pay attention to that language. So x being less than or equal to 4 satisfies both inequalities.